So this is page 2 of our interactive notebook for significant figures or significant digits. Those words are interchangeable. The definition of significant figures is that significant figures are digits that carry meaning about the precision of a measurement. And in the lab, whenever we're measuring, we're always going to estimate one digit beyond the smallest graduation on the device. And this is because even though the device might measure to the nearest tenth of a centimeter, we can differentiate between the measurement actually being on one of those lines or being in between the lines. So we can actually be more precise than the smallest graduation on the device. However, in this class, we're going to limit ourselves to only estimating a 0 or a 5 for our estimated digit. We're going to estimate a 0 if the measurement is on the line of the graduation, and we're going to estimate a 5 if the measurement is between two lines. So we're going to move to the left side of the notebook, and we are going to look at an example, or two examples actually, of estimating in the lab. So on the left side of the notebook, we have two examples. The first shows a square being measured with a ruler. And you can see that the ruler, first of all, measures to the nearest tenth of a centimeter because there are 10 graduations in between the 0 and the 1. And the second thing you can see is that that square stops right at the 1. So the device measures to the nearest tenth of a centimeter, and because it's exactly on the 1, that'll be 1.0. But we're also going to estimate one more digit. We're going to estimate our measurement to the nearest hundredth of a centimeter because we can tell that it's exactly on that 1.0 line. Now, if it were closer to being in between 1.0 and 1.1, we could estimate 1.05. And if it came all the way out to the 1.1 line, we would estimate 1.10. But because it's right on the 1, our measurement that we record will be 1.00 centimeters. The example right below that is similar, but with a graduated cylinder. This time, the cylinder is going to read to the nearest 1 milliliter because there are 10 graduations in between 20 and 30. Remember that when we're reading a cylinder, we always read at the bottom of the meniscus, which is going to be right here. And we're going to count up. That's 21, 2, 3, 4. And the meniscus is right at that 4, or at least closest to the line. So 24 is what the device reads to. But we're going to estimate one more digit. And because we think it's right on that 24 line, we're going to estimate a 0. So this would be 24.0 milliliters. And the 0 is our estimated digit. Back to the right side of the lab notebook. A lot of times in class, the measurements that we have won't be ones that we take, they'll be measurements that we're given. So we want to be able to determine which digits in a value that we're given are actually significant. So which of the digits in a measured value that is given to us are actually carrying meaning about the precision of that measurement. So we have 4 rules that we're going to determine, or that we're going to use to determine whether or not a digit is significant. The first rule is that all non-zero digits are significant. And if we go to the left side of the notebook, we're going to look at examples for each one of these. So I'm going to switch back and forth between the right and the left. So example number 1 over here, the number is 545. That would be 3 significant figures because all of those are non-zeros and all non-zero digits are significant. Back to the right side of the notebook, rule 2 says that final zeros after a decimal are significant. So back to the left, the example is 23.180. These first 4 digits we already know are significant because they're because they're non-zeros. This 0 is also significant because it's a final 0, meaning a 0 that is the very last digit of the number. But it's also after a decimal, and a final 0 after a decimal is significant. So this value has 5 significant figures. Back to the right side, the third rule is that all zeros in between significant figures are significant. So on the left, our example is 2300.00. So the first thing that we're going to do is identify the numbers that are significant based on rules 1 and 2. So the 2 and 3 are significant based on rule 1 that states that all non-zero digits are significant. And this 0 on the end is a final 0 after a decimal. So according to rule 2, it's also significant. These 3 zeros in the middle now are zeros in between significant figures. They're in between the 3, which is significant, and the last final 0, which is significant. So rule 3 says that they are also significant. So in this case, we have 6 significant figures. And then lastly, we're going to go to rule 4. And rule 4 is more of a rule about what digits are not significant rather than being a rule about what digits are significant. So rule 4 says that placeholder zeros are not significant. And I'm going to show you 2 examples of placeholder zeros on the left. The first one is in the number 2300. So the 2 and the 3 are significant because they're non-zeros, and that's according to rule 1. Rule 2 says that final zeros after a decimal are significant, and we don't have any of those because while this 0 is a final 0, it's not after a decimal. Rule 3 says that zeros in between significant figures are significant, and these zeros are not in between significant figures. These zeros are what we call placeholder zeros, and that means that there is a decimal here, and they're holding the ones and the tens place. And because they're placeholder zeros, they are not significant, so this number would only have 2 significant figures. The next example has zeros to the left instead of to the right. These are sometimes called leading zeros. They're not in between significant figures. This one, these are to the right of the decimal. They are after the decimal, but they're not final zeros. In order to be a final 0, it has to be at the very end of the number. So since they're not final zeros after a decimal, and since they're not in between significant figures, these are known also as placeholder zeros. So we're not going to count them either. So the only significant figures in this number would be the 3, the 5, and the 8, all of the non-zeros. So there would be 3 significant figures on that number. The last thing that you need to do to complete this section of your interactive notebook is glue in the Apply Significant Figures homework that you did for this section. So glue that into the left side margin so that you can still read all of your examples, and you'll be done with the Significant Figures and Digits page.